maybe we can carry up.
TOA Continuous Excellence in DSP Technology. The TOA Corporation was the first to introduce DSP technology to the marketplace back in 1988. This particular product was called the Seori, and Seori is a type of Japanese weaving, and that's basically what we do with our DSP technology. We weave inputs to outputs. The development of the DSP was continued with the introduction of the DP0202 and the DP0204. This later led to the development of the DP0206 and the current D901, which is a digital matrix and mixer. The D-2000 continues this tradition with a very large-scale matrix mixing DSP with some added features. The D-2000 can be The D-2000 comes with Windows-compatible software for programming and also for remote control, and we connect to the D-2000 via a typical TCP/IP network. The D-2000 can be utilized as a mixer, can be utilized as a matrix, or a signal processor for speaker management, typical crossovers as an example. It's modular based, so we can configure the inputs and outputs on our needs. It allows for some customization of the I/O. We also have remote control modules for custom control panels. There's 2 slots dedicated for this, and this allows us to make our own custom panels for volume up and down and scene selection and things like that. The D-2000 can also be used with the D911, which is a control surface for mixing. This is your typical analog feel to doing your mixing capabilities. And we also will need the D984 VC control module if we want to use the D911. There are 8 auto mixing channels in 4 groups with nom calculations, and basically auto mixing will allow us to control the gain of the system so that you don't necessarily have to have an operator constantly writing the gain controls during a conference when you have a bunch of open mics. As the mics come online, the system gain will decrease, and that way we get maximum gain before feedback in a open mic situation. We have ductor capability, and what the ductor capability gives us is that if another signal comes in, a paging signal or a voiceover occurs, then the channel that is providing the background music, as an example, will be ducked down to a lower level. And we can set up priorities between these priority channels, and there's 8 levels of priorities. We also have some feedback suppression in auto and dynamic mode using up to 12 filters. Auto mode is we're going to set it up for the room. It'll use as many filters as we assign for it, and it's a one-time setup. If we use a dynamic mode, then there will be filters that are automatically added as the situation requires, and you can have a combination between auto and dynamic, so you can mix the 2 modes together. Scene memories for calling back all of the different parameters that have been stored are available to us, and there's 32 available scenes. We have full DSP capabilities. We have obviously the high and low pass filters, parametric EQs. We have compressors and levelers. The compressors will allow us to maintain a proper signal level throughout the audio chain so that we don't overload the system. Levelers will allow us to control the overall level of or volume of the music, let's say, so that it is always at a given level. We can do crossovers. We can control the cross-point gains in the matrixing. And we have gating capabilities and delay. The D-2000 has 3 modules. The D-2000 is a 4-channel input module. It has mic line capabilities, phantom power, which is 48 volts, XLR connectors, and it is a 24-bit module. The output module, the D-2000 DA1, is 4 channels. It can operate from -10 to +4 XLR connectors, and it is also a 24-bit module. To connect the various units together, the D-2000 CB is a 16-channel CobraNet device. There are 2 separate channels available to us, 16 channels in and 16 channels out. And we can connect up to 4 D-2008 SP units with the CobraNet module. You can also use the modules for the D901. Now, unlike the D-2000, these modules have only 2 inputs and are 20-bit devices. Since we have 8 slots available to us for input and output modules, we can have a maximum of 32 inputs if we populate the unit with 8 input modules. 4 times 8 is 32. Or we can make a unit a complete output device and have 4 times 8 outputs for 32. And we can mix and match in any combination we like as long as it adds up to 32 on each individual unit. As an example, if I require 10 inputs and 18 outputs in a matrix, now that's a combined total of 28 channels. So we have 10 inputs. We will use 2 times AD2081, so that gives us 8 inputs. And we can use 1 D922E from the D901 series, and that'll give us a total of 10 inputs, and that's spread over 3 slots. Now for the 18 outputs, I'm going to choose 4 times the AD2000 DA1, so that gives us 16 outputs, and 1 D971E from the D901 series. That'll give us a total of 18 outputs, and we'll have 5 slots taken up with that. So now we have totally populated our unit with 3 slots for inputs, 5 slots for outputs. So we have fully populated the unit. And of course, we're obviously going to need one of the D2008 SP frames. Another example is we need 36 inputs and 20 outputs in a matrix. Now this is a combined 56-channel setup. So we need 36 inputs. We will use 9 times AD2081s. This is 9 slots. We'll need 20 outputs, which is 5 times the AD2000 DA1, and that's spread over 5 slots. And we're obviously going to have 2 frames for this, since our total slots is more than a single frame can handle. So we'll populate these 2 frames with the inputs and outputs, as the diagram to the right indicates. And we're also going to have to use a couple of CobraNet modules in order to pass these inputs and outputs back and forth so that we can have a complete configuration with 36 inputs and 20 outputs. We'll now take a look at the audio bus arrangement for the D-2000. We have an input matrix bus, we have an audio bus, and we also have an output matrix. This allows us to take our inputs and put them onto the audio bus and then pull them off the audio bus to the output matrix in combinations that are suitable for our application. On the left, we have a diagram showing our input cards, and these cards are again spread over 8 slots for a maximum of 32 inputs. And they can be a combination of the new modules or the D901 modules. We also have the CobraNet device available to us, 16 channels of input. And the input cards are connected to the input matrix, and we can set up the matrixing for the inputs on the input matrix bus, and we can also have the CobraNet channels coming from other units, other D-2000 units coming into the CobraNet and onto this input matrix bus. And this input matrix bus can now attach to the audio bus. And this will allow us to set up the combinations of inputs to outputs through this audio bus. We also have an external bus which will allow us to directly connect the input cards straight to the output matrix without going through the audio bus. We can also have the CobraNet input go straight to the CobraNet bus without passing through the input matrix. So when we have multiple units available to us, we would normally pass the output from another unit straight into the CobraNet input and then straight on to the CobraNet bus to be passed on either locally through the output matrix or passed on to the next D-2000 unit. And of course we have the output matrix, and the output matrix will pick off from the external bus or the audio bus or the CobraNet bus the signals that we want for our particular application, and then these of course will be passed on to the output cards or to the CobraNet output module. And you can see we also have some bus monitoring available to us through a headphone monitor bus. And you can see that this monitoring is available to us on the input matrix, on the audio bus, and also on the output matrix. We'll now take a look at the front panel of the D-2000. We have a large display available to us, and this will show us all 32 possible combinations of inputs and outputs. And each one of these channels has a channel number associated with it, a peak light to show us if the signal has reached a peak state, and 3 other dB levels, plus 12, 0, minus 40 dB. And this will give us some sort of indication as to where our signal is in the overall process. And if this channel is under a gate influence, the gate LED will light up to show us that that channel has been gated. And if we've selected this channel for monitoring, the little LED will light up to show us that we are actually listening to that particular channel. At the other end, we have our numeric display to show us some information about the particular scene we've selected, the device number, etc. The first little LED will be lit up if we have the front of the unit in locked mode so that we cannot operate the various buttons on the front of it. If we're going to be working with the presets or the scenes, we would select up and down with the arrow keys to go through the different parameters that are available to us, and if we were to select the next one, the presets, then we would be able to adjust the scene that we want to load up. And the same with the unit ID. If we're working with several different units and we want to indicate which unit this particular device is, we would use the up and down arrow keys to select unit, and then the unit ID will show up here. If we're going to also be working in the monitor mode, the LED would light up for monitor, and then we could go up and down and select the channel that we want to monitor once we put it into monitor mode. The console is, if we were working with an optional motorized console that is really not available to us at this time. So this particular LED indicator has no functionality for us at present time. If we go down, again, we use the arrow keys to go down to the CobraNet LED here, or system setting. We'll now be able to take a look at the CobraNet functionality. We also have some LAN activity LEDs available to us, and these two LEDs will indicate whether we've made a connection to the back of the unit through a LAN connection, and whether there's any sort of activity happening on this particular network connection. We also have some system status indicators, whether we're having problems with the unit. We're going to get an error LED light up to give us an indication that this particular unit has a problem or a failure, and also whether the system is in a proper run mode or not. We also have some CobraNet activity LEDs that will indicate if our primary or secondary links are active, and whether the unit is acting as a conductor or a performer. Now we also have a word clock indicators here. Now the word clock is going to allow us to provide synchronization between different DSP products. It's important to have synchronized word clocks so that all of our digital timings are in sync with each other. This will help prevent clicks and pops through the DSP chain if our particular synchronized clock is, if they're all synchronized together, all the clock edges. So we're going to show that the word clock has been synced up, whether that word clock is coming through the CobraNet or whether we're providing an external word clock. There's a reset button available to us. Should for some reason the D-2000 need to be restarted, simply place a paper clip into the hole, give it a press, and the D-2000 will reboot. There is a power switch available to us. There's a headphone output and volume control, and a 5-way selection buttons, up arrow keys, down arrow keys, left and right. Now the up and down arrow keys will step us through the different modes that we saw previously, and the left and right arrow key will take us through the different channels and allow us to operate on the particular mode that we have chosen. And once we're on the channel and in the mode we want, if we need to set a parameter, simply select the middle button. Moving on to the back panel, we can see that we have word clock connections. If we want to attach external word clocks to the D-2000 from other DSP devices, we would simply connect on these B and C connectors. We have a CobraNet slot where we can put our D-2000 CB module. There's the input channel and output channel, 16 channels each available to us. And we have the 8 module slots for input and output, and also control. LAN connection, RJ45, and also there's the MAC address down below for this particular device. We have RS-232 control port, and this will allow us to add in AMX or Crestron type controllers. If we take a look at the applications that the D-2000 can handle, certainly small to medium-sized systems requiring up to 128 inputs and or outputs in a mixer or matrix combination. We can install the units in a centralized location where all of the amplifiers and the DSP is in one area, and now we're going to send out the audio to all the different areas that require coverage. We can also decentralize the system because now that we're using CobraNet to connect the individual D-2000s, we can now put the different units in different buildings and pass audio back and forth through the CobraNet, providing we stay within the 100 meters of the CobraNet capabilities. And with the LAN TCP/IP connection capabilities, we can program the units, we can control the units, we can monitor the units, all using typical networking capabilities. One of the advantages of the DSP technology is the fact that we're actually reducing the cost, because if you look at the cost of trying to produce the same horsepower that's available to us in the D-2000 over several different units, it would be quite expensive. So we've reduced the number of units that are required to build up a system, and by doing this, we've also reduced the signal-to-noise issues that are associated with multiple units, with all the interconnect cables, etc., and the unit noise for each of the devices has now been reduced because everything is contained in one unit. And we've also reduced the labor costs of having to make up all of the interconnecting cables between the various units that would be required, and also the racking costs, the space requirements, and the labor costs just to physically put these units into a rack. Some of the systems that could be put together using the D-2000, certainly convention centers with their multiple rooms and public areas. This is often a matrix application to broadcast background music throughout all of the public areas, hallways, washrooms, etc. And also in some of the larger convention centers, you may have areas where you want to stage particular events, and we can certainly do that with the D-2000. Recreation centers often have swimming pools or arenas, that sort of thing, and gymnasiums as an example. And in the arenas, we'll certainly have more sophisticated speaker systems that require crossovers, and the D-2000 can certainly handle that. There's also open microphones in arenas for making announcements and instructional skating. Same for swimming pools. Swimming pools could have aerobic swimming or competitional swimming, and certainly we require, in some cases, foreground music for impact, for synchronized swimming, etc. House of worships, we would be using the mixing capabilities, and also house of worships generally have fairly sophisticated speaker systems, again, with crossovers, etc. Retail malls, often it's a centralized system with the amplifiers and the DSP all in one area, and the audio is now sent out to all the different areas, to all the different speakers in the different mall areas. Banquet halls, we'll have room combining in banquet halls where we're going to constantly change the environment, whether it's room A and B combined, A, B, and C combined, that sort of thing. And we'll use the presets to call this back. We'll use the matrixing capabilities through distributing the medium throughout the facility, and also for mixing in the individual rooms. Here's a block diagram showing a typical municipal hall application. And you can see that we've configured the D-2000 as an input device with 32 possible inputs. We have stage microphones, CD players, paging microphones, basic background music in sources, etc. And we have another D-2000 in the amplifier room that's actually going to be feeding the outputs into the various amplifiers. So we have a D-2000 acting as an input device and another D-2000 acting as an output device. We can also have in the audio mixing room, we would have a D-2000 as a monitoring device so that we can have outputs for monitoring all of the different inputs and outputs that are going on throughout this facility. And you can see that we've got a switching hub. These are inexpensive switching hubs, typical TCP/IP switching hubs, where the computer is connected, and through this hub we're connecting the local monitoring D-2000, the amplifier associated D-2000, and the input D-2000. And with this, we can have our computer take a look at the signal activity through the software, what is going on with each of these units. We can change the presets, etc., and make modifications to the signal as required through the software. And to connect the audio chain through CobraNet, we have another switching hub that is connecting to the CobraNet module. So this way we've connected all of our audio chain through the CobraNet for sending the inputs to the outputs, and then also having the D-2000 act as a monitoring device. So now take a look at a single D-2000 being used for a fitness club application. And we've configured the D-2000 to have inputs and outputs all in the same unit. We have a paging microphone. We have a couple of background music sources, TV source, a digital messaging system to announce specific events throughout the day, a timer to call up these events. Often in the aerobics room we'll have an instructor, so we'll need a wireless aerobics microphone in that particular area for the aerobics studio. And now we have the outputs from the D-2000 feeding some of our multi-channel amplifiers, and we're going to be connecting these to speakers in a swimming pool, in a locker area, in a gym, in the entrance, and in a public space for relaxing. So this would be a typical mixing, matrixing application where we're going to send medium throughout the building. We'll now take a quick look at the Windows-based software that's provided with the D-2000. Once we have the D-2000 set up for input and output module configuration, and whether we're using CobraNet, etc., and the busing arrangement, we're going to be presented with the input page. Now, anybody who's done any D-901 programming, this software will look very similar. It operates very much in the same fashion. However, there's a few extra facilities here for the D-2000 that is not in the D-901. But the overall metaphor is very much the same. So if we look at the input module settings, we would be presented with input module setup. And we can, as you can see, we've got one of the inputs set for line level of -10. That's suitable for background music, etc. type of sources. And we also have another one set up for a microphone with phantom power. We can also, once we select the trim settings, we can adjust the sensitivities of these particular inputs, fine-tune them to where we want them to be. We also have a filter set up for each individual channel, and we can set up the low pass, high pass, and PEQs to suit our needs. We also have compression and limiting capabilities, and the window pops up and it shows us all the settings that are available for compression or limiting. Auto mixing, again, this is going to be 8 groups of microphones, 8 microphones over 4 groups, and we're going to be able to assign these microphones into various groups, and this will present us with all of the different settings necessary to make the auto mixing work for us. And if we had the unit connected to the PC connected to a unit, we would have a metering available to us in here, but since this is not connected to the unit itself, the metering doesn't show up. The next window that would be available to us is the actual faders, where we can make adjustments to the inputs signals that are now going to be presented to the audio bus. Next, we'd be presented with the input matrix, and this allows us to select any of the inputs and assign them to the audio bus. And so simply highlighting or clicking on one of the squares will put one of these yellow dots to indicate that a particular input source has been placed onto the audio bus. And we also have the capability of changing the levels on this particular cross point so that we can make changes to these levels coming from inputs to go to the audio bus, but not affect the overall volumes going to other areas. So we can have multiple outputs from a single source that don't interact with each other. Next, we'll take a look at the audio bus, and this is the bus where the inputs and the outputs interact. And we have delay capabilities so that we can delay signals on and off the bus. This could be used for setting up different timings into large areas where the audio sources need to arrive at the same time, but certain signals have to be delayed so that they're perceived to arrive at the same time in the room itself. We have feedback suppression capabilities here, so available to us on the audio buses is where we would set up the filtering for it. We have fader capabilities for doing the cross-point mixing on and off the bus. And, of course, there will be metering here if we were connected to the unit itself. Now, like the input matrix, the output matrix allows us to take signals off the audio bus and place them to the output cards. And you can see it's the same arrangement. We simply select a square, click on it, and then a pin, so to speak, will be placed in that particular spot, and this will connect the audio channel on the audio bus to a particular output. And again, we have the capability of changing the cross point levels on each one of these particular cross points.
Hello, 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 hello.
And finally, on to the output software. We will now look at the data associated with the output bus. And again, and finally, on to the output section of the software. We will now look at the DSP that's associated with the output bus. And again, we would select the fader button, and up will pop the fader display window, and we can make adjustments to the volumes that are available to the outputs. And we can also set up crossovers for speaker systems, where we'd have low frequency cabinets and mid-high frequency cabinets, etc. We can set up particular crossovers suitable for that type of arrangement. And of course, we have full filtering available to us, so that we can make specific adjustments to the room or whatever the speaker cabinets require to have them operate efficiently. And we have compressors available to us to make sure that the signal does not exceed the maximum levels that the system would. That concludes our brief description of the software for the D-2000. In conclusion, the D-2000 is a DSP mixer and/or matrix. Each unit can handle a maximum of 32 combined inputs and outputs. We can get a maximum of 128 inputs and/or outputs using 4 units, and of course we'll have to use CobraNet to connect the individual units to get to that maximum. It's modular based for flexibility. We're going to use CobraNet for audio distribution between the units, whether we're expanding the unit or decentralizing the system. It's window-based software for networking, for programming, and for control of the system. We have an RS-232 port for third-party control capability using AMX or Crestron. And it's suitable for small to medium-sized venues. Thank you for joining our webinar on the D-2000.